Welcome you all to the video lecture on signals and system. Today we are going to discuss about one of the NPTEL assignment problem in the topic inverse Laplace transform. So the question is, consider the Laplace transform x of s which is given by 1 by s square into s plus 1 with the ROC minus 1 that is real part of s ranges between minus 1 to 0. So we need to find out its inverse Laplace transform. So again, given as x of s, we need to find out inverse Laplace transform. As a first step, we need to apply the partial fraction. And then according to the given condition ROC, we need to rewrite the expression of x of t. So first let us apply the inverse Laplace transform and find out what is x of t. So given is the problem x of s is equal to 1 by s square into s plus 1. So we need to apply the partial fraction. So anyway, for s plus 1, no, it is a simple roots we can apply directly, but for s square it is repeated roots. We have 1 by s square. So repeated root means first we have to consider a by s separately and then b by s square separately and then c by s plus 1. Okay. So suppose if we have s square into s plus 1 the whole square, then how will we write? A by s plus b by s square plus c by s plus 1 plus d by s plus 1 the whole square. Okay. So if we have repeated roots, how many terms we have to repeatedly write the values accordingly. Suppose if we have s cube, then we will be writing that as a by s plus b by s square plus c by s cube. Okay. So now what is there in the left hand side numerator? We have 1. Okay. So that we have to write here. Anyway, if we cross multiply everything, denominator terms get cancelled, right? So numerator in the left hand side it is 1, that you have to write in the left hand side equal to. Then take a, okay, with a what we have to multiply. So always compare this term with the denominator of this term. Okay, the original denominator term we have to compare. Here already I have s. Okay, so one s is already there. What are all the remaining terms in the denominator available? One more s and one more s plus 1 is there, that I have to multiply with a. Similarly for b, here s square is there, so s square is already there. What is not there? S plus 1 is not there, so multiply with s plus 1. For c, again compare both, s plus 1 and s plus 1 is there. What is not there? S square is not there. Okay, so multiply with that. So once we have done, we need to find out what is a, what is b, what is c. So for that, what I can substitute? When you compare, here I have s, so simply we can substitute s equal to 0. What about this term s plus 1 I have? So s minus 1, s equal to minus 1 I can substitute. Why? Because s plus 1 equal to 0, s equal to minus 1. So s equal to minus 1 I have to substitute. Okay. So two things easily I can substitute. I don't know about other values. Let me first do this and find out at least two terms. Okay, substitute s equal to 0. What is there in the left hand side? 1. So anyway, s equal to 0 means this term get cancelled, the c term also get cancelled, only b available. So b into 0 plus 1 is 1. So b value is nothing but 1. Substitute s equal to minus 1. Left hand side is 1. Anyway, this term s equal to minus 1 means this get cancelled, only c will be available. So minus 1 the whole square. Anyway, minus 1 the whole square is plus 1. So 1 by 1 is nothing but 1. And then, so third term what I have to substitute, I don't know. So simply what you can do, you can substitute some other value or you can go for the comparison of coefficient of s square. Okay. So compare coefficient of s square. Okay, so the higher power first you can start with. Okay, so to compare coefficient of s square, let me simplify this term properly and write. Okay, as one more step. So left hand side is 1, right hand side S into S will be S square. So A S square. Okay, AS into 1 will be AS plus B into S BS plus B plus C S square, right? So AS into S S square, AS into 1 AS. Okay, other terms you are writing as it is. So now compare coefficient of S square with this equation. Okay, let me consider this as 1 in equation 1. So left hand side, do you have any S square term? No. So I have to consider it as 0. Okay, only if it is S square is there, I have to take that coefficient. Here there is no S square, meaning that the coefficient of S square is 0. What about your right hand side? I have A, S square coefficient is A. Again this is S term, will not consider, S term not consider, this is constant, don't consider. S square coefficient is C. Okay, so A plus C. So A plus C equal to 0. Already we have obtained C value. Okay, so 0 is equal to A plus 1. So A is equal to minus 1. So once you have obtained all the terms, we can substitute all those things in given x of s. Okay, so x of s is given by, what is A? Minus 1 by s. What is B? 1 by s square. What is C? 1 by s plus 1. Okay, now apply inverse Laplace transform. Okay, so x of s becomes x of t. Okay, what is the inverse Laplace of 1 by s? It is u of t. You should know the formula. What is inverse Laplace of 1 by s square? It is t u of t. What is Laplace inverse of 1 by s plus a? Generally it is e power minus at u of t. So a value it differs, according to that you can write. So inverse Laplace of x of s is x of t, so minus will be there as it is. What is inverse Laplace of 1 by s? It is u of t, so write u of t. Okay, so minus u of t is there, and then plus 1 by s square. So for s square you have t u of t, and then 1 by s plus 1 means e power, what is a value? It is 1, so just e power minus t u of t. Okay, so this is x of t. Okay, so once you have obtained your x of t, okay, now we have to consider about your ROC. So the given value x of t is minus u of t plus t u of t plus e power minus t u of t. So this is the expression for the, when we apply generally the inverse Laplace transform, but they have given the ROC condition. According to that we have to rewrite your expression of x of t. So now what is the ROC condition? The ROC condition is the real part of s, okay, varies from minus 1 to 0. So just now we have determined that your x of t is minus u of t plus t u of t plus e power minus t u of t, and we know that the x of s expression is minus 1 by s plus 1 by s square plus 1 by s plus 1. So these things we require to draw the ROC plot. Okay, x of t and x of s. So see your x of s. Okay, what are all the poles available? Poles means equate your denominator to 0. So equate your denominator of your first term to 0. So one pole exists at s equal to 0. Another, when you see a second term also, the pole exists at 0. Third term also, what is your third term? Third term s plus 1 equal to 0, so s equal to minus 1. So where your poles exist, one pole exists at 0. Pole is denoted by cross mark. Okay, another pole exists at s equal to minus 1. So since it is minus 1, take it in the left hand side. Okay, and what they have given ROC, okay, real part of s. So s is equal to sigma plus j omega. Okay, real part of s is sigma. Usually we will denote x-axis as sigma and y-axis as j omega. So real part of S means they are saying that your sigma varies from -1 to 0. Okay, so this is 0. So it ranges from -1 to 0. So wherever you have pole, just put a vertical line across it. Okay, so I'll use different color. Wherever you have pole, just draw the vertical line across it. Okay, so if I have 3 poles, accordingly I will be drawing 3 vertical lines across the pole. So they have said that ROC exists from -1 to 0. So meaning that ROC lies between -1 to 0. So only at this region the ROC exists. So now coming to the condition. Okay, whenever your ROC lies right side of a particular pole. So here I am considering this as one pole. Here ROC lies right side of this particular pole. Then this particular pole is said to be causal. Whenever ROC lies left side of the particular pole, then that particular pole is said to be non-causal. Okay. So ROC lies right side of a particular pole, then that particular pole is said to be causal. When ROC lies left side of a particular pole, then that particular pole is non-causal. Okay. Once you have determined that, we have to rewrite your expression of x of t. So this is your x of t, right? So we have to rewrite. Whenever that particular pole is causal, write the term as it is. Okay. Whenever if a particular pole is non-causal, we have to replace u of t by u of minus t, and also we have to change the sign in the particular term. Okay, if it is non-causal. So these two things we have to do. So previously my expression is x of t equal to minus u of t plus t u of t plus e power minus t u of t. Okay. So according to the condition of ROC, I have to rewrite this expression. So now x of t becomes, okay. So u of t means actually this pole 1 by s is nothing but u of t. Okay, that is this pole exists at 0, right? So this particular pole exists at 0. So corresponding term, this is non-causal. Okay. Similarly, this particular pole s square is also s equal to 0. So this term is also non-causal. Why? Because this particular pole is non-causal. So 1 by s plus 1, s equal to minus 1. Okay. This particular pole is causal. So causal means write the term as it is. Non-causal means, as I said, change your u of t as u of minus t and also change the sign. Okay. So your this term becomes, change the sign means minus will become plus, u of t will become u of minus t. And again this is also non-causal, plus will become minus t, u of t will become u of minus t. This term is causal, right? So write the term as it is. Okay. So this is the ROC. Okay. So now this term you should not write. Why? Because this has been changed to this. For the given condition, your real part of S varies from -1 to 0. So according to the ROC condition, this is your x of t value. Okay. Thank you. Thanks for watching.